publish. Ni apa pula? Try not to come if possible. But if you have very weak internet connection, then you can go to campus. Just stay at home. Inshallah. All right. Let's go to our. This is your Google Classroom. You can download chapter 6 here. And then let's finish our last chapter, chapter 5 here. Inductor in series and parallel. Okay. Bismillahirrahmanirrahim. If you look at the series and parallel of inductors, they are basically same as capacitor in series and parallel. Only the difference is inductor in series and parallel, it takes like the resistor. Inductor is same, almost same as resistor. So if you go to here, this is inductor, and then you apply KVL around the loop, this thing, and basically the voltage source here will be equal to voltage drop across all elements in series. So you will have this equation, and I hope you still remember what is voltage equal to. For inductor, voltage across inductor should be equal to V equal to L di dt. Okay, and then since all current in series have the same current, then you can put at one side like this. And then the summation of all inductor in series basically will be equal to inductor, equivalent inductor in like this form on your right side here. Okay, we have like how many people here? 38. Okay. And then so L equivalent here is equal to this L1 plus L2 plus Ln plus dot plus Ln, number of inductor in series. Okay, for parallel, yes, you can do KVL at this node or this node, and then if you build up KVL at that node, you're going to have this equation. What are they? The current source here is basically going to branch out to here, here, and here. Okay, and then equivalent to this equation. So the voltage across all inductance in parallel like this going to have the same voltages. So you can put at one side like this, and the parallel of all inductance in parallel will be equal to this L equivalent like this. So basically, what is L equivalent? It is equal to L1 in parallel with L2, parallel with L3, or so on. So if you have numbers of inductance in inductor in parallel, so you're going to have this equation like this. Just use your calculator to have this. So is it equal to that resistor in parallel? It takes the same, right? If you have this, so it's almost like the inductance in parallel. Okay. Like this. Okay. What about voltage divider and current divider? So let me take another one. Control N. Right. So if you have the voltage source in series with inductor, L1 and L2, and this is voltage source, and this is voltage drop across the L1, and V2 is a voltage drop across L2. Then what is V2? You need the source voltage PS, and then this one also will follow the resistor, not the capacitor. It will follow resistor. So the law should be voltage 2. It is a voltage drop across L2 here. So you're going to take the L2, okay, and then divide by all the series with L2. So L1 plus L2. You're going to have this. And then look at the sign. This is a plus. This is also plus. Then you're going to have plus there. This is V source. Okay. And then V1. What is V1?
VS.
Yes, V source. And then
L1.
L1. And then
L1 plus L2.
okay, nice. And then what about the sign? This one?
Positive.
Positive, because plus with plus. If you have plus with negative, then negative. Okay, that's number one. Second, if this is in parallel, sorry for the drawing. Okay, this is IS, I1, and I2. This one should be small s. What is I2 equal to? You see the L1, L2. This one also will take like resistor, current divider for resistor. So you're going to have IS first, and then this is current at 2, current flowing through inductor 2. So you're going to have that opposite, this one. So this one should be L1 over L1 plus L2, like this. Okay, and the sign, this is going up and this is going down. What this one actually, a current source here will branch out to I1 and I2, since the same direction like that, it's going to have a plus. What about I1? Can you guess?
IS.
Yes. And then?
L2.
Yes, L2. And then?
I1 plus L2.
Yes, very good. And then the sign?
Positive.
Yeah, very good. Okay. All right. So in conclusion, keep. Let me have a new slide. If you have, this is under DC condition. Under DC condition, the capacitor is like what? And then inductor is like what? The way you're going to remember this is like, maybe if you forget, this is under DC condition. So if you pull out the capacitor in opposite direction like this, and there's a big gap. When you pull out apart from each other, you're going to have something like a very big gap like this, right? So this is like an open circuit. So this is how you remember the DC condition, my way. So if you want to remember this, this is how you should replace a capacitor under DC condition. You will have an open circuit. For inductor, this is inductor. The way you remember this, you're going to pull these two ends apart. And then what will be, this one looks like, it will have a stretching like this, a short circuit, something like this. So if you want to replace, if you have inductor under DC condition, it will have something like a short circuit, even though this is, the element here is still there, but you're going to have a straight line like this, a short circuit, a short wire. And you know that there's a current flowing like this. And for voltage source across capacitor here, you will have something like this. Okay. Remember to replace and then put the voltage. And remember to replace inductor with a short circuit like this, and then place the current current flowing through that short circuit. So this is how you remember the DC condition, under the DC condition. And then we're going to have that one under DC condition. Later we're going to have an AC. So AC will have a different way how to solve the problem. But it is a very interesting chapter. I hope you by now you already master your DC part, because up until chapter 6, yeah, I forgot to mention, up until chapter 6 we are still under DC condition, even though we little by little we are going to move to AC. Right. For chapter, if you look at the slide, this is ACE 1311_6. 6 means in sequence. But from your textbook, you're going to look at chapter 9 and 10. Why chapter 9 and 10? Because we skip the op-amp. Op-amp, you're going to learn it in electronics. All right, chapter 9 and 10, this is all about AC. And if you look at the title, it has phasor. Phasor is a condition under AC, and then a steady state analysis. This is a time-based analysis. Sekejap, ada orang baru masuk. Ramai. Okay, we look at what we are going to view. For chapter 9 and 10, this is for your final, you're going to have four questions. For what are they? Later I will brief through that. But for chapter 9 and 10, this is for your question number 4. Okay, question number 4. We only have 4 questions, and this one will take you like 3 hours. And then this question number 4 is your AC. Okay, so we're going to learn the sinusoidal under steady state analysis, and then phasor form, and what the relationship of phasor with the circuit elements. And so far we have all 3 circuits element: inductor, capacitor, resistor. And then we're going to have impedance and admittance. Impedance, I think you already know this in your maybe math class, is it? Impedance. And admittance is one of impedance, reciprocal of that. And then you have phasor analysis. This one, basically all methods that you already learned in your chapter 1, 2, 3, 4. So you already learned voltage divider, current divider, and then current divider, and then mesh analysis, nodal analysis, superposition, apa lagi? Source transformation, and so on. So you're going to reapply this under phasor form, or we call it as a AC. So far so good. Is it interesting? Interesting, right? Okay. If you look at this is a resistor in series with capacitor. And if you look at this one, what you have here? Is it a sinusoidal or a DC? A DC or AC? Which one? DC, right? So this one not AC. How do you know? This one basically a 10 volt. It will give you, under ideal condition, it will give you a straight line of 10 volt. Okay. So basically this is under DC condition. So you already learned this. What going to happen to resistor under DC condition? A resistor will still have a a resistor. It will not be replaced with a short circuit or anything, right? So a resistor, still a resistor. Why I mention this? Because in other section, when we had our discussion, some of them, they replace resistor with a short circuit. So it's not a short circuit. Only inductor will be replaced with a short circuit. And then under DC condition, what happened to capacitor?
Replacement short circuit.
No.
Open.
Yeah, capacitor, right? Capacitor will be replaced a open circuit like this. So there's open circuit. So what happened to the circuit now? This is a DC, and then some resistor. Then this is open. It will looks like this is a 5, something like this, right? An open circuit. So it is almost impossible to answer this condition, but you can apply something. Why I say impossible? Because if you're going to determine with some time base here, or we call it a steady state, condition. What is a steady state condition? It is depends on time. Okay, depends on time. If you graph this voltage or current will depends on time t here. So it is almost impossible to answer this using this DC condition. So basically, you're going to apply AC if you want to have this valid. And how to do this? You can apply this sinusoidal, okay, a waveform. If you start from 0 like this is a sine wave. Can you see this? Yes. This is a sine wave. And what is this one? Omega here. From your math class, I think math, you have omega, which is equal to what? Have you heard about this? Do you know this? Omega or
Yes. Yes.
yeah, this is angular frequency, right? Angular frequency is equal to 2 pi f. F is a frequency, right? So how do you find f?
1 over time.
Very good. T is a period. Okay. So where is that in your circuit here? This sinusoidal form. Where is that T?
0 to 2 pi.
Yeah, very good. I have to test you because some of you forgot this. Okay, from 0 to 2 pi for this circuit. But basically, what is a T? T is when you have your any sine wave or any pulse or triangular or something. As long this is a signal, it will start from maybe somewhere like this one. It start from 0, and then we'll finish at also 0 like this. One cycle or one period of time like this. So you're going to have one period of time, which is equal to 1 over f. Okay. All right. And then this is a sine wave because it starts from 0. But if you have a cosine wave, it will start from here. Okay, it will start from here. And then it will finish up until here. Okay. Then same, frequency is equal to 1 over t, or t, a period, is equal to 1 over f. And then if you look at this, you have a sine wave here, but with a plus theta. If you compare with this part, okay, if you compare with these two, this part will not have a plus theta. No, There's none. There's none here. So why? Because it's t plus 0. Okay, it's a plus 0. So what are they? Since this is a plus 0, or we say that a theta there is equal to 0 degree, we don't need to write down that. Okay, no need to write down. So that's why in the equation there, they remove the plus sign there, plus 0, and then they remove the bracket. Only this part, only this form. In your second class, we usually, we don't like the sign wave. Okay, kejap saya dah record belum? Kali tak record. Okay, recorded. Bagus. Okay, so we don't like the sine wave. Even though this is a signal, V1. And if you realize this is a small letter. V1 is a small letter. And then VM is a capital letter. Oh, by the way, what is VM? We haven't touched about that. We only touch about omega. Omega is the angular frequency, which is equal to 2 pi f. But what is VM? VM is the amplitude. So where are they? Sekejap, saya padam semua. VM is located at here. From 0 to maybe here. Okay, this is VM. Or if you have a cosine there, then this is your VM. So what is V peak to peak? This one later on you're going to learn in your lab, but I want to stress out because later the instructor will not explain on that. So V peak to peak is actually from this peak to the other peak. This is V peak to peak. So if you relate with VM there, VM is equal to V peak to peak divided by 2. So this peak until the negative peak. So you're going to have a peak to peak and divide by 2 because it's going to have an equal VM. So far so good. VM is a magnitude, right? Why I said that in our second class, we will not really go through the, we don't like the sine wave. We want it in cosine. So you're going to convert from sine to cosine. So how to do this? There's some rules that you need to follow, which is equal to, this is a cosine, okay? This one you can write down. This is a sine, and the opposite of that is a negative sign, and the opposite of cosine is negative cosine, like this, okay? And how to convert from where to where? Basically, I only remember one part, which is from sine here. If you want to convert to cosine form, then you need to minus with 90 degree. Okay. If you go counterclockwise, you need to minus 90 degree with every quarter of this. Okay. If you have something like this, if you follow clockwise direction, then this one will have a plus 90 degree. So only remember one so that you don't confuse yourself. Okay, I usually remember that side. So I will remove that part. And yeah, you need to remember one portion. If you look at the signal V1 here, we have a VM sine omega t. And if you look at here, this is a sine, right? And there's no positive or negative in front. But you know that this is a plus, right? Plus sign. So if you look at the, this, what we call this, this graph, then sine, because we want to focus on the cosine, we want to have everything in cosine form. Then sine to cosine, you need to minus with 90 degree. Okay, minus with 90 degree. So with this one is actually equal to Vm cosine. Oh, kejap. Tak nampak sini. Vm cosine omega t. Omega t, can you guess what is next step? Next step. Omega t minus 90 degree. Okay, this is how you convert it to cosine form. So Vm cosine in bracket omega t plus 90 degree. So basically here in this form, we will have what? The theta here is a negative 90 degree. Okay, for this part is this negative 90 degree. Later, you will understand what I said here. It's just to stress out that you're going to have everything in cosine form, not sine. All right. Do you have any question? In summary, for this sinusoidal form, you will have a cosine and sine, but usually you're going to have a cosine to solve your question. And what is Vm? Vm is the amplitude. This is amplitude. What is omega? It is angular frequency, which is equal to 2 pi f. And then what is that theta? Theta is the phase. Okay, phase. It's different. Oh, yeah, this phase. All right. And the phase is basically starting from 0 right here. And if you have it in this side, you have a negative, and this side will have a positive. So later on, maybe we go through one example, then you will understand this better. Okay, this one already explained. Okay, if you look at this part, if you want to compare two sinusoidal form, sinusoidal wave means any signal. If you have two signals, then you need to compare with same frequency. Okay, same frequency. Okay, by amplitude and phase you already. Okay, what does it mean by this? If you have maybe this is a V1 with some Vm and then sinusoidal and then omega t, like in our previous explanation, and then Vm cosine omega t plus theta. If you want to compare these two signals here, you need to have this sinusoidal and cosine same in order to compare. Meaning to say this sinusoidal form, you're going to convert first into cosine, and then only you can compare these two signals. Okay, so that you can get the theta here and then the Vm. Okay, this one very important. And what this 2 pi f, this 2 pi f, you will have some information in there, but bear in mind that you're going to have the same omega 1 and omega 2 here, so that you can compare each other. Okay, omega and omega 2 should be same, and then only you can compare. So basically, there's two things that you're going to compare. You're going to see first, the sinusoidal and cosine should be same. And then the omega here, the angular frequency also should be same, so that you can compare each other. Okay, let's see the example here. Maybe you have not clear with that example. Tapi this one, not that example, later. Okay, this is a one sinusoidal signal. And then you need to calculate what is the amplitude. Amplitude you don't need to calculate. Can you guess what is the amplitude from this signal? Oh, kita dah ada solution. Tak apa. Okay. The Vm is equal to 5. But what is the unit?
What?
This is in volt. Yeah, because I put V. If I put IM, then this one will be 5 amps. Okay. The signal can be in current or voltage. Okay. What about phase? Phase
Degree.
negative 60 degree. Okay. What about angular frequency?
Four pi degree.
4 pi. Oh, I forgot to put the unit is in radian per second. Okay. Angular frequency, the unit is in radian per second. So this is 4 pi radian per second. And what about period T? And you know that angular frequency is 2 pi f, right? So how do you find this? And you know that frequency is equal to 1 over T. And you can find from this, just substitute into f here, then you're going to have this. So what is your period? What is your period? 2 pi divide by f, right? Frequency. Okay?
Okay.
Okay, semua dia. Okay, and then okay, so this is 2 pi over betul ke ni? Kau saya yang salah. Okay, this is 2 pi is equal to this. So yeah, betul. And then frequency is equal to betul lah. Period 2 pi divide by the 4 pi. Betul lah. 2 pi divided by 4 pi. Then this one you can cancel out. Then this is half. Since T is equal in second, right? T is in second, then yeah, should have that second there. And then frequency is equal to 1 over T, which is equal to 1 over 0.52 Hertz. Okay, ke pening? Saya buat awak pening. This one. Okay. This part, this is what I explained previous. If you have this sign and this cosine, they are not same. You cannot compare. Okay, you need to convert this into cosine in order to have a same cosine form. Then you can compare these two signals. What about angular frequency? These two are same. Then you can compare this part. Okay, fine. And then you need to figure out, is this leading? The signal here, is this one leads or lag? The I2 here. So what should you do? First, you're going to compare. But before that, what is I1 in cosine form? What is I1 here? The signal 1 in cosine form. Anyone? This is sine, this is cosine. Then you have negative sign here. This is negative cosine. This one, negative 90 degree. So what is I1 equal to? And if you look at here, this is a negative sign, meaning to say it takes the negative sign here. And you're going to convert into cosine form. So what is this one?
Plus 19.
Okay, good. A plus 90 degree. So I1 will be equal to 4 cosine, because you already converted to cosine. And then this one 377t plus 25 degree, then plus 90 degree. Why plus 90 degree here? Because of this part. So far so good, right? Okay, and then this is what you're going to have, 115 degree. Is it okay?
Okay.
Okay.
Okay, Alhamdulillah. And then, apa lagi? Okay, the next step is your I2. 5 cosine 3770 minus 40 degree. Okay. Are these two same or not?
Same. Oh,
Same. Very good. What about these two?
same.
Yes. Now then, you can compare these two signals. If these two are same, then you can compare the signals. What does it mean by compare? Okay, next step. Next step. Okay, what is that 377? This is angular frequency, okay? And this is in radian per second. Why I put it this way? Because later on you're going to have this. So I'm going to keep on remind you on this. So since these two are same, then you can draw the signal in this form. And is it leading or lagging? Okay. But previous I said which one is on the right side and which one is the left side, right? So if you look at here, this is a plus 115. And the second signal have a negative 40 degree, minus 40 degree. So if you look back at your circuit here, on the left side of the zero form here, you have a negative, right? A negative. Sekejap kau saya yang salah Sebentar ya. Nanti kan silap. A plus. Ke saya yang salah ni. Aduh. A plus. Plus theta. Plus theta. Plus theta. Plus theta. This one should be left side actually. Plus theta. I think I give you the wrong direction. This part should be a plus. Kejap Sekejap. Pening nanti awak. Keep. This part on the left side should be a plus. On the right side should be a minus. Sorry, because if you look at this, saya besarkan. This is a cosine. I give you a wrong direction. If you look at here, this is a cosine, right? This is a cosine. I give you a wrong direction, and then this is a cosine form, right? Why I say cosine? Because it starts from 0 here. But if you look at here, this is a plus theta. So it should have a plus theta on the left side. Okay, this one should be a plus. And then on the right side, since we don't have any omega t plus something, then the left side should be a minus like this. Okay, this is through a correct way. Okay, plus on the left side, and then on the right side should be negative. Okay, so if you go back to our example here, because I confuse you, sorry. So this is a plus should be on the left side, and then the negative here should be on the right side of this 0. Okay, so how to draw this? The I1, it should start from here, maybe somewhere. You just draw the thing, and then this is a plus 115. Okay, a plus 115. So start from here, a plus 115. What about 40? I draw with different color. Okay, different color. This one, something like this. and this is 40. You cannot see here because I'm going to zoom in. Okay, this is 40 degree. 40 degree from this 0 pi. Okay, and this is the black color signal here is your I2. Okay, I2. So which one is leading and which one is lagging? Sekejap. This is I2. And which one is leading and which one is lagging? If you just look, which one comes first? This is I1, right? So I1 is leading the I2 with how many degree? With the theta, which is equal to 115 plus 40 degree, which is equal to 155 degree. Okay, so it should be by 155 degree. Is it clear? I have to zoom in and zoom out because I cannot draw with different color. And then, there's answer there. So I want to avoid the answer there. But basically, if you look at the answer there, you will have this. Okay. Do you have any question?
No.
No, eh? You just look at this one should be a plus on the left side and the right side should be a negative. And since this is a negative, then this is going to be 40 degree. And then the plus sign on the left side, so it should be 150. So the phase difference is 115 plus 40, it should have 155. And then which one is leading? You look at which signal comes first. So I1 comes first, then I2. So I1 leads I2, all right? Or we can say I2 lags I1. That's another way to see this. I2 lags I1 by 150. Okay. All right. Listen. From DC, we're going to move to AC realms. So phasor form, a phasor is a complex number, yes, in complex form. It represents your amplitude and also sinusoidal, amplitude and phase of the sinusoidal. Or simply put this way, if you draw the imaginary axis and real axis, you have some phase of the sinusoidal form, and then these are this one is your amplitude. So phasor has three form. One is the rectangular, second polar, and then third one is exponential. Okay, so rectangular form, it takes the x-axis and y-axis. So you have maybe, I just put it in this form, the z is equal to x plus jy. X here is the real axis. The j is the imaginary axis, IM. So if you draw this into this imaginary axis and real axis, you have, this is IM, imaginary axis. And this one is the real axis. And how do you relate this? If you look at it, this one, this is x and this is y, right? So x form is the real form. You need to plus the imaginary is y. So you have a y there. This one you always write j first and then the imaginary part. Okay, and this one just like your math, x plus gy, then it will be equal to this z. Z is the amplitude. Okay, they put in this form. Sometimes we put it in R, but since this is the direction, so z is equal to x plus gy. And what about a polar form? Polar is when you have the amplitude here with some theta. So you're going to convert this into that. So this is x plus gy. In a polar form, you need to have some phase. So this is theta, and then the magnitude r. Okay, so z is equal to this. Basically, they are all same. And then exponential, you need to have some magnitude. Magnitude is r. And then you have exponential. And then j. J of what? J of that theta. J of this one. Is it okay? Later maybe you're going to have it in a simpler form. I'm going to explain you one by one so that you really do understand in AC form. So like your math, if you want to find the amplitude here, this is equal to x squared plus y squared under square root 2 here. So this is like math. And then what is theta? Theta is equal to inverse tangent y divided by x. Okay, this is your math, y divided by x. So you can find that using math problem. Tengok jam. Okay, we still have like half an hour. Okay. Do you have any question before we move to Euler's? Euler's identity? Any question? No?
No.
No. Right? Okay. The last one here, this is the exponential part. And what is the magnitude of this form? Can you guess?
1.
1, right? The 1 in front of that. And then if you put it, this is exponential, this is a rectangular form. And we know that if you have it in rectangular form, this is x. And maybe you have a 1 here. This is magnitude, okay? And this is theta. And from your math, you know that how to find x. X is equal to what? X is the cosine of theta. Is it true or not?
Yes.
Okay. What about y?
Sine.
Yes, sine theta. Okay, that's why if you look at the rectangular form here, the cosine or the real axis here is equal to cosine theta here. Okay, and the y here is equal to sine theta. Okay, so if you put it in this form, real and imaginary, then this one you will have this cosine and sine. What about complex conjugate? This is interesting. I do not know that maybe you learned this from your math, but I just re-explain it here. So if you want to have a complex conjugate, then conjugate it. If, let's say you have this in this form, x plus j, imaginary, and then y. This is z, okay? So in complex conjugate, you're going to have that asterisk on that amplitude there. So, and then you're going to conjugate the plus sign here. So this is x minus gy. You're going to opposite that. So that's why you have a minus there, x minus gy with this asterisk. Okay, you look at the asterisk, and then this one is invert. What about in polar form? If you have that in polar form, let's say you have z, which is equal to amplitude, and then you have a theta. So if you want to conjugate this form, this one you have an asterisk, and then we have the same r, but what we are going to conjugate the phase. So you're going to have a negative theta. So far, so good. Okay. And then what about in exponential? Let's say you have exponential form amplitude with E exponential and then J theta. Then in complex conjugate, you're going to have asterisk of that amplitude. You have a R here and then E negative J theta. Okay. Only opposite that or conjugate that sign. So you're going to have this. So far so good, eh? Just stop me if you confused or something. Okay, this is maths operation. You going to use this only that when you cannot use your calculator. Okay, only use this when you cannot use your calculator. Right. Basically, this additional and subtraction will take the same form, and then you're going to have it in rectangular form. Okay. And then this multiplication and division. Actually, why I say rectangular form, because this is easier to solve this in this form, okay, in rectangular form for additional and subtraction. For multiplication and division, divide, you're going to have in polar form. Easy to solve this in this form. And then reciprocal, this one basically just a rule. All these four, there are just some rules that you're going to try to understand that. So if in rectangular form for plus and minus here, if you look at here, this is real and this is, this Z1 and Z2 is basically two signals. So you're going to have the real with real of signal 1 and 2. And then the imaginary part is the signal 1 and signal 2 of that imaginary part. Same with minus. This part, the real part, and this one, imaginary part. For multiplication, you can multiply the amplitude and then you can add the phase. Okay. For division, you can divide the amplitude, and for phase, you can minus. You can do the minus. And then for reciprocal, basically this is a Z inverse. Okay, a reciprocal. And then how to solve this? You're going to have this Z inverse is going to have inverse of amplitude, and then you have a negative theta. Right. What about this Z square root 2? This is in this form, right? If you put in mathematically form, this is equal to this. And then it is basically you can square root 2 R. Square root 2 R. And then divide by the theta, you can divide by 2. Okay. Because sometimes you cannot use calculator. So you're going to apply this rule. Why I put 1/2? Because sometimes you cannot see what is that square root 2 in this form. So I put it in 1/2. So if you have amplitude in maybe 1/4, like this, or this one basically 4, right? Something like this. So you need to understand this is in this form. And how to find that? You have an amplitude of this form, and then you can divide by 4. Okay, the theta here, divide by 4. And so on. If you have 3, then this one, you know that the amplitude can be use this form, and then theta divide by 3. Okay, and so on. Conjugate, you already know this. Okay, this one explain. And then Euler's identity, if you have, saya tak boleh zoom. If you have a plus sign, then you're going to have a plus. Cosine theta plus J sin theta. But if you have a negative form, negative, then this one will be cosine theta minus J sin theta. By now, I hope you please do not fall asleep. Okay. Do you want to do exercise on this or not? I prefer you guys to do this, but using your calculator. The thing is, I'm not going to show you how to use calculator because I already made one video on this. Maybe later I will give you the link and then you try this example. But please use calculator. It's just that you need to make sure that you use complex form. You have your calculator, right? Set the mode in complex form and then make sure this is in degree. These two, okay, complex and degree, so that you will have a correct answer, right? This is half and then something. This one in rectangular form and then this one in facer in polar form. Okay, maybe for example number 3, I'm going to give you the video first and then you will do the example and then we go back to discuss on this. Is it okay? Is it okay?
Okay.
Brothers and sisters? Okay?
Yes, madam.
Alhamdulillah. Okay. Then, but if you want to try it by your own, then just go ahead. It's just that sometimes you cannot use calculator. If you cannot use calculator, go back to this mathematic operation of complex number. You're going to apply any one of these 8 rules. And you are lucky because this is an open book. Later you're going to have final, right? So you can refer back to the mathematic operation of the complex number. This one already explained. Okay, this form. 1. You're going to write down what is the equivalent expression for the following numbers. This is 1. Okay, number 1 here. So what is this? Any volunteer? What is 1?
1 plus 0j.
Pandai, bagus. It is 1 plus, usually, yeah, we say plus 0j, but in writing form, j 0. But usually we don't put it in, this one no need to write down, so that's why you have a 1, only 1, okay? But for your understanding, you need to understand this in this form. And then how to put it in this one, the polar form first. Polar form. Can you convert the 1 here into polar form? Can you guess? What is the theta? Okay, macam ni lah. Maybe you don't see clearly. Oh, tak boleh draw pula. Sekejap. Macam ni. This is a real. This is a imaginary. If you draw this, how this one looks like? This is a real. This is imaginary. So how this one looks like for IM and real here? Okay, for the first one, maybe I draw for you. Real should be at real axis, right? So this one should be here. This is 1. Okay. Do you see any phase different? The theta here. Do you have any theta there?
No.
No. So meaning to say, what is theta equal to?
0.
Yeah, very good, 0. So you can write down this is 0. And what is the amplitude? if you write down this form, you know that in rectangular form, the arc or amplitude is equal to 1 square plus 0 square, right? And do the under square root of this. You will get what?
1.
1.
1, right? So 1 here is basically the amplitude. So you just write down 1. Okay, so far so good.
Yes.
Okay. What about exponential form? This is E, okay? So what is that J here? And you know that this is amplitude, which is also equal to 1. And then this exponential, is it a positive or negative?
Positive.
Positive. Okay. I think this one positive or negative doesn't matter, but you need to know that what is the theta from here?
0.
0. So if you use your calculator, exponential 0 will get a
1.
1.
1.
Basically, it is a 1. So you don't need to write down this form, but you need to understand if you want to convert it to this exponential form, then this is a plus j theta. Okay, right. Second, you have 1. This is, what is this one? In polar form or rectangular form or in exponential form?
Rectangular form.
Polar form.
Rectangular.
Ah.
Polar, right? Polar.
Polar.
Polar. Why polar?
Polar.
Because it has the face. So you have this part. Okay, so it's a polar form. If you draw this, this one will looks like this, right? Is it correct or wrong?
Second quadrant.
This form. Second quadrant. Yeah, very good. Saya salah. Because it exceeds 90 degree. Macam mana ada orang baru masuk. Okay. Second quadrant. Yeah, very good. So it should looks like this is 90 degree, and then it will go this part, something like this. 135 minus 90 degree, you will have a 45 degree here, right? So always refer to that 45 degree there. And then, okay, why are you late? This is real axis, this is imaginary axis. And how do you write down this in rectangular form? What is x and what is y? This x, is it a positive or negative?
Negative.
Negative, right? So you have a negative cosine 45 degree. Is it right or wrong? You have x is in negative form. And you know that this is 1, then this amplitude should be 1. So negative 1 cosine of 45 degree. What about y? Is it a positive quadrant, a positive imaginary axis or negative?
Positive.
No.
Positive.
Yeah. This one is this. So if you write down this in terms of rectangular form, you're going to have what? A negative cosine 45 degree, then plus sine 45 degree. Or you can write down in terms of square root 2 divided by 2 or 1 over square root 2, I think. The negative sign. Depends on you. But you have a J there. Don't forget that J. Okay? In cos, that one is in rectangular form. What about in exponential form?
E,
What is the amplitude?
1.
Okay, E, and then we have J. Is it a positive or negative?
Negative
Negative. What degree?
45.
For 45, I think. Yeah, if you want to write down in 45 degree like this, or you have a 1E, a positive, J 135. Okay, I think if you use your calculator, you will get the same. 1EJ 135 degree. Okay, maybe I just pick one more. Why we learn this? This one just to make sure that you can directly draw this using polar form or rectangular form or in exponential form. Okay, what if I use this one? How the 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 axis looks like? Actually, this one more interesting if I give you the what we call that, the whiteboard, and then you draw. So one with 90 degree. What is that? This is real. This is imaginary. How this one looks like? 90 degree means start from the real axis up until this. We have 90 degree, right? And then where is that amplitude?
Imaginary.
Very good. Imaginary, this part. And this one, we have a 1. Okay. And then what is this one in rectangular form? Do we have any real axis?
No.
No. So it should be 0. And then this is a positive, right? Positive imaginary axis. So a plus. Then G with what? With
G90.
is it 90 or just 1? 1, right? It's a 1 because you have imaginary at that side. So it should be a plus J. Okay, and then or we write down a plus J. And then in exponential, this one will be a plus J 90 degree. And amplitude is 1. Okay? Okay or not? Or you confused? Oh, okay. Maybe we have another one. I think this one. One with 180 degree. In rectangular form, what is this one equal to?
Negative 1.
Negative 1. What
Plus
about plus?
G0. G0.
0.
Yeah. Because what? Because our axis is at this side, right? 1 with 180 degree. This is real, this is imaginary. So you have a negative 1 plus J0. And then in exponential, equal to what?
Negative E.
Negative, is it negative? Yeah, kalau boleh juga negative or positive pun okay. But you need to write down in J 180 degree, something like this, right? So a plus minus E J 180 degree. Kalau if you have a J 180 degree, then this is a negative, negative 1. But if you have a negative J 180 degree, exponential negative J 180 degree, then this amplitude will be a plus. Okay, I think all of you do understand this. Okay. Okay, can we transform this part? Sekejap, ada orang baru masuk. Kenapa lambat? Sinusoidal form into phasor. There's two signals. Okay, two signals. So how to transform this? We know that phasor have three forms. Okay, the rectangular, and then polar, and then exponential.
Exponential.
Yeah, very good. So we have this. This is what? 6 is amplitude. Okay, this one
Theta.
phase. Theta is a phase. So what is this one in polar form first? Oh nama, terbesar pula. Polar. Polar, and then kita rectangular, and then exponential. Tapi the thing is, I think the most important part is these two. So I think we better concentrate on these two. So what is this one in polar form? By the way, please make sure this is in cosine form, because I said in our C usually, so make sure if you have this one in cosine, yeah, you don't need to convert it. But if you have a negative sign like the second signal V here, then you're going to convert it to cosine form. Okay, so this is sine to here, this is negative 90 degree. So what is the number one? The current. If you want to convert this, if you look at here, this is a small letter. Small letter means this one in I with respect to T. Okay. So if you want to put it in phasor form, this one will be in capital letter. Okay. And then we know it. So what is this one equal to? What is the amplitude?
6.
Yeah, very good. And then theta?
Negative 40.
Yeah, correct. And then if I put it in terms of rectangular form, what is this equal to? 6. And then? We need the amplitude and then cosine theta, right? So this is the form. And then a plus or minus. A plus or minus. Actually, if you draw this one, it is at this part, right? This is 40 degree. Then this one will be negative G sine 6 sine 40 degree, something like this. Okay, but usually I love to convert it into polar form than this form. This is very lengthy, and we might have a wrong negative or positive. So you just stick with one. Okay, this number one here. And then what is V? Like I said, you need to make sure this is in, yeah, convert first to cosine form. So what is this in cosine form? In cosine form, this one will have a what? A plus 90 degree or a minus 90 degree?
Plus.
A plus. Why plus? Because if you look at our graph here, we have a negative sign, then we convert it to cosine, we have a plus 90 degree this part, and that's why you have a plus 90. So this V is actually equal to 4 cosine 30 degree. Oh, sorry, we have T 30 degree plus 30 T plus 140 degree this part. So in polar form, what is this in polar form?
4.
4.
4 with
140.
this one. Okay, so if we put rectangular form, this is 4 cosine 140 degree, and then plus J for sine 140 degree. But I want you to have it in this form. All right, very good. Okay. Okay. Kejap there's another one. If you look at your textbook, usually the I here and the V here, they are bold, and then capital letter, bold and capital letter. This means they are in phasor form, but it's hard for you guys to bold the capital letter here. So what should you do? You put a bar, I bar, something like this. Or you can put I like this and then the bar is down there. Just make sure that this is capital letter and you put some bar sign. But sometimes they just ignore. But for you guys, usually I put a bar sign here. So that you can different with the amplitude. Tapi amplitude pun sama, tak apa, nantilah. I will, something like this. For, if you type this one, then you can have a bold. But, tapi susah kan nak write down. So you're going to have this. Okay, now, do we still have time? Oh, dah habis waktu. Shall we stop here or you want to continue until we finish this part? We're going to convert sinusoidal to phasor form. Maybe later lah. Maybe later, inshallah, later. So you're going to revise back on this part. Okay. Do you have any question before we end? Attendance? Sure. Let's see, attendance. Google form. Sorry, I almost forgot. Let's give you the link. Okay. You can fill in and maybe some of you wants to ask me a question. You can ask me. And some of you asked me about the quizzes and the assignments. So far we had how many assignments? 2, right? 2, and then quizzes we have 3. Do you want more or you just you think that this is enough? In our agreement from our week number 1, we only going to have 2 assignments and then 3 2 assignments and 3 quizzes. But it's up to you if you think that your carry marks very bad because of that 2 assignments and then 3 quizzes. Maybe you want more, then you can agree to have another. But if you think that that's enough, then we just proceed with our 5 assessment for carry marks.
Can we know our carry marks?
Belum. We haven't. I haven't marks all. Only one and assignment.
Alright, madam.
But from your bottom from your bottom of your heart, maybe you know that what's your carry marks at. Okay. But you can, yeah, maybe I can give some polls and then you, yeah, I will try my best to give you your carry marks soon as possible, and then we're going to finish our chapter 9 and 10. End of chapter 9 and 10, maybe if you decide to have more on assignment or quizzes, then we have that. Okay, we still have like 2 weeks before we finish our semester, and then your paper will going to have the first day. Yes. Yes. You want to ask something? No, eh? Okay. So I will give you that pool, and then maybe later on, maybe after you have your carry marks, inshallah. Okay. Can we stop now, or you want to proceed with something? If no, then we finish with tasbih, kafara, and surat al-as. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Nas